Akil cepatlah, start kereta lambat dah ni nak tinggal. Dah lah panas.
Kau enjin dia tak boleh hidup pula.
Aduh, tak boleh start pula. Tengok buka bonet. Mana bonet pun? Akil hantar aku apa-apa pasal enjin.
Mana aku tahu apa-apa hantar.
Takkanlah tak tahu, aku pun tak tahu ni. Macam mana dia fungsi ni?
You guys want to know how the engine works?
Duduk dia cakap.
Angguk je lah.
Let's go!
In physical chemistry, thermodynamics deals with how work and energy in the form of heat are produced and consumed that is also used to model engines. Thermodynamics allow us to ignore the complexities of the mechanical system and concentrate on the engine's input and output instead. In thermal engineering, engines are machines that use thermal energy to produce work or use work to modify the system thermal energy. Yes, so how does it work? Good question. So a combustion engine in a car is a thermal engine as it uses gas or fuel and an electrical spark to produce a controlled explosion that generates energy and heat. The energy is then transformed into movement using the car's mechanical components that we call as work. A thermodynamic cycle is also a series of processes performed by a thermal engine that involve heat and work. For example, we have Carnot cycle, Otto cycle, Rankine cycle, diesel cycle and many more.
In this part, I will explain about Carnot cycle. Not carrot, but Carnot. Carnot cycle is an ideal thermodynamic cycle. It is prepared by French physicist, which is Sadi Carnot in 1824. In Carnot cycle, a system or engine transfer energy in the form of heat between two thermal reservoirs, which is from hot temperature and cold temperature. Carnot is an ideal theoretical engine that is free from all the imperfectness of an actual machine. Carnot developed the foundation of the second law of thermodynamics and is often called or described as a father of thermodynamics. Okay, so this is the Carnot cycle, and you can see in the graph, which is the pressure against the volume. There are four phases, which is from A to B, B to C, C to D, and D to A. So for the first process, which is from A to B, is undergoes isothermal expansion, which is the heat will enter the system and the piston or the system will be pulled up and the volume will increase while the pressure will decrease. So for the B to C, which is adiabatic expansion, the system is expand adiabatically. So for the third process,
Wait. What is actually isothermal expansion and also adiabatic expansion?
so for isothermal, we see that isothermal is there are no change in temperature, which is the temperature is also constant. So also in adiabatic, in second law of thermodynamics, adiabatic is there are no heat transfer from the surrounding to the system. That is isothermal and adiabatic. So we go further, which is from C to D is isothermal compression, which is the system is compressed isothermally, which is the heat will be compressed and the piston will go down. So the last part, which is the D to A, is adiabatic compression, which is the system is compressed adiabatically. In this process, there are four process: A, B, B, C, C, D, D, A. This is a reversible process.
The Carnot cycle is the most efficient engine possible, which is in 100% efficiency based on the assumption of the absence of incidental wasteful process such as friction and assumption of no conduction of heat between different parts of the engine at different temperature.
But in actual practice, there is friction and dissipation of heat whenever some work is done on the system. There is no such device that acts as a perfect insulator or perfect conductor. Also, processes in Carnot are being conducted at a very slow rate, which is difficult to carry out. In real engines, the heat transfers at a sudden change in temperature, whereas in a Carnot engine, the temperature remains constant. In our real life, there is no such engine with 100% efficiency.
So, we don't apply Carnot cycle in explaining how engine works?
Well, technically yes and no. Carnot engine is an ideal situation. It sets a limiting factor, though not possible to make it in real life. So, to explain how internal combustion engines that uses petrol or gasoline work, such as automobiles and lawnmowers, we can use the Otto cycle.
Okay, for Otto cycle, it is quite similar to Carnot engine cycle. But for Otto cycle, it starts from here, where the intake of air and fuel, it goes to point 1 to point 2, where the adiabatic compression happen. Then for point 2 to point 3, isentropic compression happen. This is where the combustion occurs. Then for point 3 to point 4, this is where the adiabatic expansion happen. And for point 4 to point 1 is isentropic expansion continued by the exhaust process. So for point 1 to point 2, piston roll up, so it can compress fuel and mixture compression, causes the mixture to be increased slightly in pressure and temperature adiabatically. When reach point 2, fuel is met by the spark plug to be ignited. Then for point 2 to point 3, combustion occurs due to the ignition of fuel by the spark plug. Combustion complete at point 3. Highly pressurized chamber has a lot of heat, aka the thermal energy. This is referred as an isochoric. Then for point 3 to point 4, the thermal energy is used to do work on the piston pushes down the piston, resulting to the increase of the volume of the chamber. And this process is also known as the power stroke. Thermal energy is turned into motion to power the machine or the vehicle. And then for point 4 to point 1, all waste heat is expelled from the engine chamber. As the heat leaves the gas, the molecule loses kinetic energy, resulting to the decreasing of the pressure. Then the exhaust phase occurs when the remaining mixture in the chamber is compressed by the piston to be exhausted out without changing the pressure. So that's how the engine works.
Mana Mamat Hijau tadi?
Itu lah tu dah cakap punya banyak enjin tak hidup lagi. Kereta lain dah parking.
Aduh, dah lambat ni dah. Jom kita duduk private je lah.
You say I don't wanna go, baby don't cry, hope you don't cry.